What I want to do today is cover the idea again of lists and files just a little bit more, and then I want to hit the idea of classes. Classes are incredibly important to object-oriented programming languages, of which Python is one. However, Python lets you do a whole bunch without learning classes. But if you want to learn them, you can.
Like everything we've done up to this point.
Right, everything we've done up to this point is vaguely had a little bit to do with classes, just because things like strings are classes and lists are classes, but we don't know that.
Yeah, so like most of what we've done up to this point is without knowing about classes.
Right. So for example, we've done import, don't type this stuff because I'm going to delete it immediately. T is equal to, turtle.turtle, like that. And then we've set some stuff, like I'm going to make my turtle go really fast. And I want the color of the turtle to be red. Something like that. And I want the turtle to go somewhere. I'm going to send them to, some place in the Northeast. So T, in this case, and you can type these notes if you want. Maybe I won't delete them. I might make them a comment. T is an object of type turtle. And we see here that it's got several different methods. A method is a function that is attached to an object, or at least part of the class. So we see several methods here, right? That's a function, .goto, .color is a function, .speed is a function, and that is a function. That's a special kind of function. That one's known as a constructor. I'm going to put some comments out here. This is a constructor. A constructor is used to create an object. Quite typically, you can put stuff in the constructor. As you could say color is equal to red, and put all sorts of cool things like that when you create it. I don't know if the turtle supports that. But usually, if you're going to make a constructor, the reason you're going to do so is so that you can pass in bits of information that are really important. So what I would like to be able to do is something like this. S1 is equal to square, and it's not a square if I make it a rectangle. R1 is equal to rectangle, and it's a 10 by 20 rectangle. And then print R1 dot area, like that. And print R1 dot perimeter. That's the kind of thing that I want to be able to do. And this is probably more important than lists and files, which are adequately covered in the textbook. So we may focus on this and then go back if we feel like we have a lot of time today. So that's what I want to do, is I want to create a class called a rectangle, and we're going to need some bits and pieces of information in it, right? What all did the turtle have to have? Well, we see that in order to work, the turtle has to have a speed, it has to have what color it is, it has to have a position, and what we don't really see here is that it's got both a fill color and a pin color. And it's also got a state about whether the pin is up or down, so whether it's drawing or not. And you can change the thickness of the pin, and each one of those is controlled by another method. You can do T.set thickness. I don't really remember if that's what it's called. Or T.pin up, T.pin down, T.begin fill, so that after you draw your shape you can call it end fill. Those are all methods. And so they all imply bits of information. Begin fill would set a flag, a Boolean variable, saying, okay, I'm in fill mode. Maybe something else that has to go along with it, and like its starting point from when it did that. So we can kind of surmise that this thing's got a lot of data going with it. Now our rectangle class probably only has two pieces of data in it, a height and a width. You may think that, you're also going to store the area and the perimeter as variables within it. But no, if you have something that looks like a calculation, you don't want to store it as a variable. And getting the area from it is a calculation. Getting the perimeter of it is a calculation. Now, why do I say you wouldn't want to store the area? Because you could. As soon as you create it, then you could turn around and set a variable inside it that was equal to, 10 times 20. But what if later on you provide a method for changing the height? Then if you change the height of it, to 20, then the area is invalid. It is stale data, right? Because it's still thinking that you have an area of 100. So it's better to go ahead and write a function that will calculate the area every single time you need it, so that you're getting nice fresh data. Otherwise, you can drive yourself crazy trying to make sure that these variables are, updated with every call that could change these values. And with only 2, that wouldn't be a big deal. But if you had a complex object, it could be a big deal. So, yeah, like the turtle has a bunch of information. So you could think of, the area and the perimeter. You have the option of caching that data in it, so that you wouldn't have to calculate it every time. But you don't want to do that. You want to create methods that would calculate that stuff. So I'm going to comment all this stuff out. And then I guess I did it in Notepad.
Yeah.
All right, I'm going to fire up idle here. And we're going to create a class. It's going to be a class called rectangle. It's going to have 2 members, a height and a width. Am I going to spell it out or just, like that? 2 member variables, height and width. And it's going to have 3 methods. It's going to have a constructor. The constructor is what creates it. And then it's going to have get area. And then it's going to have get perimeter. So that's our information. That's where we're going for. I'm going to create a new file and bang these notes over to the side so that I can just keep track of where I'm going with this. Now, the syntax for defining a class in Python is quirky, to say the least, compared to languages like C++ and Java. It's almost as if Python was invented not to be class-oriented, object-oriented to begin with, and then they bolted it on. I don't know if that's true or not.
It feels like that to me, too.
But feels like that, yeah.
When we did Java in my high school, it was like, very first day, it was like, Java's object-oriented.
Exactly.
We're doing objects.
You have to do objects just from the get-go, day one in Java. And you don't have to in C++, but you can. That's just because C came before C++, and you can learn straight C before you start doing the objects. In Python, you're using objects the whole time. Okay, so what are we going to do?
In fundamentals, it's like, Python is an object-oriented language.
And then we never mentioned it.
And then you never said objects again.
Okay, so the way if you were going to define a method, you would use a def keyword and then give it a name. Mm-hmm. Well, we're going to define our class with the class keyword, and I'm going to call it rect. A very creative name. And I need to make a constructor for it. The constructor in other methods, don't type this. In other languages, a constructor would look like this. It has the same name as the class itself, but not in this language. So we're going to define a function within it. And if I say the word method, I mean a function that is attached to the class. And if I say function, I should have said method. Those are 2 underscores right there. And then the word init has to be that exact syntax. 2 more underscores. And then we're going to put some parameters here. Every method in a class in this language has to have a variable that references self. Self is the name of the object, or it is a reference to the object itself. And I'll show you what I mean. For now, I'm going to make one that does not let you specify the height and the width. We're just going to default it. And so self.height is equal to 10. And self.width is equal to 20. And if we feel like it, we could stick returns, but that's optional. All right, now we're going to define a get area method. Define get area, def space get area, and again I have to have a reference to myself. And so what is the area? Return self.h times self.w. And let's do one more. Define get perimeter, which again has to have a reference to itself. Now when we call these functions, we're not going to pass anything in. We will see that very soon. And the perimeter of a rectangle is 2 times the height plus the width. So 2 times self.h plus self.w. And that's the end of our class for now. And here's what using it looks like. R1 is equal to rect. And then print R1, well, let's put some explanatory text in here. Print area equals, end quote, comma, R1 dot get area. Parentheses in parentheses. Like that. And then call get perimeter the same way. So print perimeter equals, end quote, comma, R1 dot get perimeter. And do you have to space your stuff out like that? No. I just like putting lots of space in. Okay, so we created one and it defaults to having a height of 10 and a width of 20. So when I print out the area, it ought to be 200. When I print out the perimeter, it ought to be, I don't know, 60, something like that. So I'm going to save as, and I wouldn't save it as the word class since it's a keyword. I'm not sure if it would break it or not. I'll just give it one of our old boring names. April 3, yeah. April 3.py. Now let's see if I goofed it up. Okay, so as predicted, the area was 200 and the perimeter was 60. Now at this point, our class does not support setting the height and the width or changing the height and the width. They're hardwired to 10 and 20. And that's kind of dumb. So 2 things we could do. There's more than 2 things we could do. We could provide ourselves with a set area, a set height and a set width, or we could allow the constructor. Or even better, both, because once you create it, you may want to change the size of it. I'm just going to do set height for now. And then I should do a walkabout, make sure that we're all good, because I know that some people walked in late. Alrighty, so def set x, and again we have to have a reference to ourselves, and we're going to pass in an x variable. If you define a function, it's called a parameter. When you pass a parameter, when you pass in a value, that's called the argument. So what we're going to do now is we're going to say self.x is equal to the value that we passed in. Just note the syntax here. Otherwise, you'd just be saying x is equal to x. That would be a little weird. It wouldn't know. So it uses the that reference to hook this up. Now, honestly, you don't have to call it self. You could call it Bob if you wanted to, as long as you use the same name inside your methods. You could say get area parentheses Bob, and then you could do return bob.h times bob.w. And you could be totally inconsistent and call this one Fred. Return 2 times Fred.h thing. That's one of the things that makes Python look really odd if you want it to, as compared to Java, for example, where you have a reference called the this reference. And if we wanted to, if I wanted to make it look more like Java, I would replace all the words self with this, but self is the standard canonical reference to itself. All right, so I need to test that. I have a set method, but I haven't used it yet. So r1.setX, I made mine with a capital X. Yours just has to look exactly the same. Not the same as mine, but when you invoke it, it has to have the, the same case. So I'm going to set my X. Why did I call it X? Do I have an X variable?
No.
No. All I have is a height and a width.
I was going to ask why you did that, but I thought you did it on purpose.
Nope. This does create a brand new variable called X, but that was not my goal.
Anywhere.
Okay, so I'm going to change those X's to height, to H. So it should be set H, and I'm very sorry about that, guys. That line should be set H, and you pass in an H argument to fill in that H parameter. And we say self.H is equal to H, and I'm very sorry about that mistake. And down here, when we call it, you better change that as well. Make that set H. Pardon me? Okay. All right, so the area was much larger. And I could provide a set W as well. Feel free to add one, while I'm doing walkabout or whatever. One more thing I want to add before I go and check with y'all. Maybe I'll slow down just a little bit. Is let's give ourselves the ability to specify the height and the width up here. So I'm going to add a comma up to my init line up here and add two parameters, comma H, comma W. And then I'm going to set self.H equal to H and self.W equal W. Now I've broken the code because this is no longer going to work. Why? Because we're not passing in any arguments to fill in H and W. We could put in default values, and that would actually be the wise thing to do. It says missing the required positional arguments. But I'm going to go ahead and fix that. I'm going to pass in 20 and 30. So I just added two arguments to this line. And now's about time to make sure that I haven't lost folks. Go ahead and give yourself a set W. And then what if you wanted to know that value? You would want to do a get H. And so I'm going to go ahead and add that one, and then I'm going to walk around. So the last method that I've got right now to my class is going to be called getH, and it's going to return self.H. Now, I'm not calling it, but why did I have that? Because I might want to find out what the value is. So I could call, x is equal to r1.getH, parentheses in parentheses, and then it would tell me the value. Colloquially, these are called getters and setters. In computer science terms, they're called mutators and accessors. This is a mutator because it changes it. That's an accessor because it gets it, right? Accesses it. All right. Wouldn't it be nifty if we could do this? Print my rectangle.
Yeah.
But we can't. If we run it right now, all it's going to print out is some hashed address right now.
Oh.
And that's not real useful.
Interesting. I thought it would be syntax error.
But we can make a function that would return a string version of this method. And if you've done Java programming and you remember the toString method, that's exactly what we're going to do. So two things I want to do is, one, I want to add default values up here so that we don't have to specify data when we create it. It's great if we do, but we don't have to. So why not H is, what is the default size of our rectangle? Let's make it a 1 by 1. So on this line, init, make it the default height equals 1 and the default width is equal to 1. And now let's create a string method. We're going to have to use those double underscores again. And when I mean double, I don't mean one on each side, two on each side for a total of 4. So DEF underscore underscore STR underscore underscore. And again, we have to pass in self. You just have to on every single method inside your class.
When you define a function inside of a class in PyCharm, after I put the first parenthesis and press enter, it just types the self.
It puts it in there for you. Yeah. Okay. And then what is our string going to look like? I don't know. Percent rect. I'm going to mangle the syntax on this. Sorry, guys. Percent f, comma, percent f, end parentheses, end quote, percent, and then we're going to pass in a tuple consisting of self.h and self.w. And I know that syntax is whack, sorry. But it's the same as when we were printing. We've done printing like this occasionally. More commonly, the style that they introduced with Python 3, they have the placeholders, the curly braces 0 and the curly braces 1. And I just haven't totally retrained my brain to use that, so I'm using the Python 2 style. Now that I have that, if I haven't goofed and made a syntax error, when I print it out, here's what it printed. So it actually printed a good representation of the data, rather than just that hashed address, which is of no use to us. Maybe if we were debugging the language itself, it'd be great, but it's not good for us. Along with str and init, there are a lot of other methods that you could add. It's actually called overriding in other programming languages.
Okay.
So, for example, if you want to be able to compare two objects, if R1 equals R2, right now all it would be doing is comparing the address to make sure that they were references to the same object. But you wouldn't want to do that. You'd want to compare the width and the height of the two.
Oh yeah, Java would do that with a dot equals.
Exactly. In Java you use dot equals. In C++ you would overload the equal operator. So they all have the same idea. They just have to get all different on it. Okay, so we have one rectangle down here. Let's create another rectangle with no parameters. So R2 is equal to rect, and just don't specify anything. And print him out as well. Print R2. All I did is tack that on above the R1 stuff. So if you're going to have a syntax error, it's probably going to be in that line right there, just because the syntax is kind of mangled. I ought to change that to the Python 3 syntax real fast, but as soon as everybody gets it fixed, I'm going to mess it up for you again. Anyways, so when we created the rectangle, the first one didn't have any parameters being passed to its constructor, to its init method, so it just defaulted to 1, 1. But the second rectangle we create passes in, 2 arguments to fill in the height and the width, so the default values are not used. Even more awesome is if you use named parameters, so that down here we could say h is equal to 20 and w is equal to 30 or whatever, and that way you could specify them in any order that you wanted to, but that's kind of getting far afield from where we are. I do want to make sure that you got this change in, the str and the init. And for funsies, I want to rewrite this one so that it would use the Python 3 style, but I'm going to comment it out. Return rect, a placeholder for that value, a placeholder for that value, end quote, comma, dot format, and I would pass in self h and self.w.
So with that style, how would you make it so that, like, if you had a table, that it would make sure all of them are lined up properly?
You could specify the width and the height as part of this.
Okay.
And do I remember how to do that? No, that's why I usually skip it. But you could Google up, Python formatting .format, and it would probably tell us how to specify the width and the height and stuff like that. Somewhere. So yeah, you can Google it. You can specify the type, how many decimal places, how wide to make it, whether they're left and justified, all your usual goodies that you can then specify also with %F, you know, with these percent symbols. It's just that this also works in Java and I believe in C. So I've gotten so used to doing it that way that I never really remember to do that. This is my go-to syntax. All right, so we have defined a class. What I was thinking about doing was going on and doing another class for handling a file, for opening a file, reading all of its contents, and turning it into a list. That'd be kind of fun. I don't think it would take too long to do that. But I want to make sure that the last couple of things we added didn't break the code. So, are we all good?
I wonder if my placeholders are
Yeah, that's right.
Is it? Okay.
That's right.
Okay.
Yeah, it's printing out like 6 places after the decimal point because I did not provide.
I'm not getting that.
If you did %.2f, it would print only 2 places after the decimal.
Oh, that's printing from R1. Do you have your email already?
Good to go to your
So you're just printing R2, but then you're printing area and perimeter from R1.
Yeah, but like, you turn it over string, the whole thing.
Oh, that's before he added this. So if you don't add that, then it just prints out like the internal
Classes are
identifier.
always capitalized.
Prints out something weird.
Pardon me?
useless.
Our class is always capitalized, your first letter.
You don't have to capitalize your classes, but it's considered good behavior.
Yeah, it's like a usual thing.
Yeah.
Okay, so I'm going to scroll down here past all this stuff. And here's what I want my new class to look like. I want to be able to do something like this. D is equal to data, and then pass in some file name. Maybe even the same file name we're editing right now. And then D is equal to, list, my favorite one-letter variable for list, is equal to D dot get as list, like that. So looking at it, it looks to me like we only need one variable. Maybe 2 if we want to store an empty version of the list. But I don't think we really need to do that. We could just build the list on the fly, just like I said. Now that would be pretty bad syntax, pretty poor programming, pretty poor performance to make it so that you had to every time you called get as list, it would have to hit the hard drive in order to pull it back in again. You know, what if we were doing this as, 2 megabytes, of data, or a gigabyte of data? You wouldn't want to have to read it in every single time. But let's just roll with it. That's how I want it to work, and then I would like to be able to print out my list after that. So what's my class name? It's data. Yeah, so DEF data
What's it?
colon, except the word is not DEF,
Okay,
it's class.
So it's a class. Okay, right.
And now I need to create the constructor, the init module, DEF underscore underscore, 2 of them, init underscore underscore, self, comma, and then file name. And then guess what I'm going to do? Self.filename equals file name. Self.filename is equal to file name. Alrighty. I think I mentioned a couple of weeks ago when we last hit file reading that there's one command that'll read in the entire file as a single object, which you can then play with, or you can read it in line by line. I think we ought to read it in line by line myself. A little bit more programming, but we're okay with that. I shouldn't say it's a little bit more programming. It's just different. Okay, so DEF space get as list. And since we're not passing in anything here, I just have to define it with the self-reference. So what I'm going to do next is, I shouldn't even define it as a self because that's creating another member variable. I'm just going to create it as a local variable, L. And I'm going to make an empty list, and then we're going to add on to it with a loop. So let's do with, and I don't recall if we did this syntax. What the with statement means is whatever's after this, go ahead and do it all, but then when it falls out of scope, it lets the garbage collector take care of it. So with open, and then our file name, excuse me, self.filename, because we don't have a local variable named file name, we only have a member of our self, comma, quote, R for reading. And then for every line, oh, I goofed this syntax. With open, self.filename, I probably should have just done it the other way, as F. That's going to be our file. And then for every line in F, dot read lines, I really should have done it the other way. This is starting to look alien. L.append, and I never remember if it's add or append in this language. Somebody tell me.
Well, append is a method.
Well, we'll go with it then. Add that line to our list. And then we're going to back tab so that we're underlined with the with, we're in the same scope as the with line, and we're going to return our list. Now, it's possible that's going to work. I have no great confidence. And it did. I'm shocked. Now, it'd be nicer if we ran through the list and printed it line by line with a for loop. So I think I'm going to make that change.
Yeah, I just have one long line. With the
Right, it looks pretty lousy right now. So I'm going to replace that print L with a for, S for string, in L, print S. We'll just print our list out line by line now. And now it's looking nasty. What should we have done to our data so that it didn't look this nasty? It's got a blank line between everything we print out.
Change the ending. The end.
We could do two things. One is that we could put an end parameter on our print statement. The other is that we could trim the data before we append it. Or strip. Why did my brain freeze on whether it's trim or strip?
It's strip.
Alrighty. So, I think I'm going to do that. Right there where we have for line in F colon read lines, the next line is going to say L.append line dot. Can we do a R strip so that it only does the end of it? Because the tabs at the beginning are useful information. Yeah, and there we go. So it's opening our own file and printing it line by line. So that's what I changed here. And of course, if you did L strip, it would remove all the white space at the beginning of the line. And what kind of white space are we deleting at the end of the line? Well, most importantly, it's the /n. Because when we call read lines, we're getting the entire line plus the /n that terminates the line. which is the entire line. So we're using this to remove it. We could also use, dot replace to get rid of all the backslash ends. There's several different ways of doing it. Or we could put an end equals empty string there. But I think I like it the way it is. And there's a lot of blank lines at the bottom of it, but that's all right. And if you wanted to make it open some other file rather than just ourselves, that'd be totally cool. What would be really neat is after we got it as a list, we could process a list. What if it was a list of numbers with multiple numbers on the same line and then multiple lines, and we wanted to add them all up, get a sum for each line and then a total at the bottom? We could do that.
A bunch of hash codes.
All right, before I go ahead and hit
John Ritter.
our online book about this, I would like everybody to get this last class to work. I hope the book teaches this method. I honestly don't remember. But what this is allowing us to do is to not call close on it when we're done with the file. It automatically closes it once it falls out of scope. So by the time it gets to here, the file gets closed and we don't have to sweat it. I think I posted a notice to the effect, but remember how I said you could have, you could come in and sit in on my C class and take the exam. My Java class, like only 4 people are showing up, and so we have that many seats. So the date that I specified would be a great day for you to come in, stick your fingers in your ears while I'm teaching Java, and, take your exam. You want to do it in a classroom environment.
That's Thursday, right?
It would be next Thursday, yes.
It's Thursday at what time?
Same bat time, 5:40.
Did you say it was open book?
Yeah, it is open book. Which becomes important if you bought it on a tablet. This would be the only way that you could actually get to use your tablet, is if you take it in the classroom. I'm sorry about that, but the other places just don't let you use tablets because you could be cheating with them. But I trust you.
It's probably chapter 14, objects.
Yeah. All right.
Probably.
Isn't that interesting? Take a peek at all this. If we create an empty list and then we do a directory on the list variable, we get a list of all the methods. Including our favorites like insert and pop and so on. Can we actually get to where we're defining the class? All right, so here they've defined a class called party animal. And they set a local variable, not something that, Well, that's interesting. So this is interesting. I did not realize that you could do it that way. So we have a variable, and it looks like we're giving it a default value there, and then in our constructor, every time we call party, it increases that by 1. And the reason you would do it that way is because if we want a variable that continues to exist even before the constructor is called. And so if we wanted to make our code look like that, we could have done so. And honestly, I forgot that we could do this. I like doing it that way anyways, but we could have gone in and said H is equal to 0 and W is equal to 0 there. So why didn't we prefix them with self dot? Because we don't have a self-reference, right? We only have a self-reference here.
Yeah, because it's already in the class, so they're already class variables, so we don't need to put the self. Does that make sense?
We may as well play with this stuff. If we do dir on it, we know what it's going to do. And then we can get that individual method out of, member variable out of it with an.x. Let's print out the directory and the type of one of our rectangles. So we're going to go back to our code. And maybe here, where above where we've defined class data, let's print the type of R1, and let's, print parentheses type, parentheses R1, and let's print out the directory of the attributes, so dir R1. And honestly, we probably should copy and paste that and put it at the bottom of our list because we have a whole bunch of stuff printing, right?
I just commented out the for loop.
Yeah. So I'm going to yank those two. I'm going to Control X them, and I'm going to paste them there. So underneath our for loop is where I'm putting that stuff. Yeah. And I said pring. It's obviously not what I wanted. Print. So when I printed the type of it, here's what it said. Underscore, underscore, main, underscore, underscore. Where have we seen that before? When we were writing, a self-invoking, when we were calling our main method. And then dot rect, that's the name of our class. And this is a list of all the functions within our class. And we have two member variables, H and W. We had a set H. I never added a set W. We have get parameter, get H, get area. And then we have all these other methods that we did not override.
They're like default.
Yeah, so LE, if you wanted to be able to compare two rectangles based on whatever criteria, like whichever one's the tallest or whichever one has the most area, you could override that one. You could provide a method for LE, and it would do some kind of comparison and return which one was larger or not. Same for some of them. I have no idea. Reduce, don't know.
The EQ is.
Yeah, EQ would compare two of them. GE is greater than or equal to, LE is less than or equal to, LT would be less than,
GT is greater than.
GT is greater than, and so on. So do I have an assignment over classes? I need to ogle that. Why am I looking for that word? All right, the sphere class. No, not submissions. Let's say what we want to do is write a class called sphere, which is going to have one member variable, radius, and two methods, get area and get volume. Now you can see that where we're going with this is remarkably similar to what we just did. Get area returns the surface area of the sphere. You can Google that formula. If you can't find it, text me. Get volume returns the volume of the sphere. Same comment. Have your code create several spheres and print out their surface areas and volumes. Now this is part one, step one. So is there anything more interesting than that? Not really. Okay.
It's step one. It's the entire thing.
Yeah.
Just
the entire thing is step one. Alrighty.
Step one. Complete the assignment and turn it in.
And so step two is going to be add a string method which returns a string representation of your object. And add, should be an, EQ method, which returns true or false if both objects have the same radius. Now, I didn't show you how to do an EQ method, so
I made one for the rectangles.
so I did it on the fly. Okay. So let's go back and add an EQ method to our rectangle class. And correct me if I get this wrong, because you said you've already done it. Let's go back up to the top, and somewhere in here, we're going to do DEF underscore under. Now this is not in the data class, it's in the rectangle class, obviously. DEF underscore underscore EQ underscore underscore. And we need to be comparing ourselves to an other object. Now this is going to look a little bit odd, the way that I write these. If self.h is not equal to other.h, and there's plenty of other ways you could do this, return false. Excuse me, capital F. And then on the next line, unindented again, if self.width not equal to other.width, return false. Now sure, you could combine those with an and, or you could write something that was an or something like that. But if you have 30 or 40 different attributes, I like ruling them out like that, rather than trying to write one mega if that would check all those cases.
So the and statement.
Right, right. So, and then lastly, if, you know, if we haven't been proved guilty, then we're innocent, and so we're going to return true.
That's pretty much what I have if self.h equals other.h and self.w equals other.w, return true, else return false.
Right, right. Let me make sure I don't have a syntax error there. So I'm going to run the module. It's not going to behave any differently. All right. No syntax errors. So I'm going to test it out. Right here where I did R2 is equal to rect, you see I'm tacking on something more right here. R3 is equal to rect. And then I'm going to say if R2 is equal to R3. So this stuff's the new stuff, right? Right there. Then print R2 equals R3, else colon print R2 does not equal R3. Now they should be equal, right? Because we're creating two with default values, so they're both 1 by 1 rectangles. After you've seen it print that they equal, pass in two parameters into either R2 or R3 and make sure that it will print not equal. And I'm going to have to scroll way up to see where it did that. Yeah, right here. At the very top of my output, it says R2 is equal to R3. Then if I want to test to see if they don't equal, I should add two arguments. Like 10, 20, something like that. To either R2 or R3, and then run it. So I'm going to tack on a little bit more to this.
You could be really silly and see if the area and the perimeter equal, instead of looking at the height and the width.
Yeah.
Next one is due the 30th.
So at that point, you will have a fairly full-featured class. And what do I mean by that? It'll have the ability to turn itself into string. You can compare them to each other. You lost. All right. Hope I started the recorder again when I went. Okay, yeah. All right, I'm fairly happy with this assignment. You pretty much know how to do this just based on what we've done. So you could pretty much just copy the code, make a couple of changes, and you would be good. I would encourage you to struggle with it a little more than that. I would encourage you to try to do it, maybe not based from memory, but go ahead and look in the textbook how to create a class. You know, Google online, go to this chapter 14 of our online text, that kind of stuff, rather than just, you know, I think our example's pretty clear, but you don't learn nearly as much just by copying what we do in class and then, you know, changing the 5 things that it would take in order to get it to work.
For some of the homework that I did last weekend, I copied like a bit of code from last semester
Yeah.
for its homework.
Need to see the code again? Sure thing.
I mean, one of them was like a summation py file.
Right.
And we already did a summation assignment.
Yeah. Every teacher's going to make you do a summation in
Well,
every
no, we did a
language.
summation of one in this class already.
Yeah.
What is a weak reference?
Sorry?
What is a weak reference?
Well, that's a good question. Rather than
I'm
me,
Googling it, but it's kind of.
rather than me pretending I know.
Well, it's weird. It's like it said it's deleted, but it's still there. And
A weak reference to an object is not enough to keep the object alive, meaning that the garbage collector is free to destroy it. However, until the object is actually destroyed, you can play with it. That's bizarre.
yeah, that's
Weird. So you can just read data from memory that is
And you
marked
ho-
for deletion but not yet deleted.
And you hope it's still there.
And you just kind of hope it's there.
That's
How do you
bizarre.
know when the garbage collector is going to throw it away?
You don't.
You really don't. So that's pretty stupid. I bet that there's a way to check to see if it's still there. You know, hey, are you still there? Otherwise, you know, you could be referencing something that was not. But that's a good question. I'd never researched that before.
There's frozen stuff.
Well, that's a module, not necessarily like an aspect of a class, is it? Or that,
Yeah,
those kinds of
it was
things.
listed as one of the methods in the class.
In the directory.
Yeah.
Yeah. Yeah.
So you could make a method that would cooperate with this weak ref class, would be what I would assume.
Or you can make a list of if something's going to be deleted.
Subclass. Yeah, there's a lot of these that just look really weird. Weak ref.
All right.